Hello and welcome to Embedded Internals. This is sixth episode of our series, Pointer Thinking series. Double pointer explained. Most of the developer understand this, whereas they got confused when we see this or this. So in this episode, we are going to know what are double pointers, triple pointers, why would we need a pointer that needs another pointer, where are double pointer actually used, how do operating system, kernel, embedded firmwares use them. Everything start with a simple question. We know, for an example, int x is equal to 10. Inside the memory, let us assume at 1000 a value reside 10. Then comes the integer pointer, which store the address of x. So the memory corresponding to is, let us say, 2000, where the address of x, that is 1000, resides. Can something store the address of this pointer itself? So answer is yes, we can store the address of pointers also. Due to that, there comes a new pointer, double pointer q, which stores the address of p. So here is q. Let us say this is at address 3000, which stores the address of pointer p, that is 2000. So this is pointing to this location. So q is containing the address of p and p is containing the address of x. Similarly, when we have triple pointer, so 3 indirection operator r, it will store the address of q. So when we say the complete memory, it will be like pointer r has address of pointer q, which has the address of pointer p, which has the address of variable x. So this is 4 level of addressing. So it is like, think as pointer containing the address and double pointer containing the address of pointer address. Double pointer means a variable which contains the address of pointer variable, another pointer variable. So when we have to dereference this variable using the pointer r, so it will be first dereference, it will second dereference, third dereference, fourth dereference. So we have to use this to dereference the variable 10. Similarly, by q, we have to dereference it 2 times. When we have to dereference this variable using the pointer p, we simply used this and we get the value. So this is like level of indirection. This is 1 level indirection, 2 level indirection, 3 level indirection. So chain will be r pointing to q, pointing to p, pointing to x, and x containing the variable. Okay, so we can, so it is like double pointer are not very complicated pointer. It simply means need access to pointer itself. Triple pointer need access to double pointer. Double pointer need access to pointer itself. Pointer is pointing to variable. Okay, let us see this in our terminal. There is a variable x which has a value 10. In one pointer ptr, we have stored the address of x, and this is a double pointer. We have stored the address of pointer itself, and printed x ptr, value stored by ptr, the address of this, and the value stored by ptr, which will be the address of pointer ptr and double pointer ptr. So ideally what the answer should be, x is 10, okay, ptr will be some address like 1000, okay, and value stored at ptr, it will be 10 again, and double ptr, it will be some address, some different address, 20,000. Value stored at ptr will be the address of pointer, which is 1000, and double pointer, so it is dereferencing to the value, which is 10. Okay, let me compile and check the answer. See, 10 some address, okay, and this is the address stored in this double pointer, because double pointer is storing the address of our pointer. So address of pointer is this is storing the address, and ptr is some address. This is double pointer address, and dereferencing double pointer gives the result back. Okay, so similar to the what we have written. I hope this is clear to everyone. Next is why we need a pointer to pointer. Double pointer is pointer to pointer. So why do we need? Let us take an example. We have a function change. We are sending integer pointer to it. Okay, and inside this function we have changed pointer to some value. So in this function we have changed the pointer. So now if like main function is calling this function, will the main function get the changed result or the same result? There will be no change because whatever has changed inside this local function is changed on the value. It does not have changed any address. So in the callee function, changes will not get reflected as only local copy changes. And this is called as pointer passed by value. Let me show you the address mapping of the above function. It is like when we have a caller, their pointer is pointing to some address, that is this, and we have sent this as function pointer. When we send the pointer from the caller function to the local function, it receives the copy of pointer. So at the callee function, the address mapping will be 2000 pointing to 1000. Okay, some address. Whereas at the function, the address mapping will be copy, so a new address which is pointing to 1000. So they are two separate variables. Changing this will not going to reflect at this address because two different addresses. That is the reason we changes are not being reflected. Changes because the pointer stored at the caller is at some other address, whereas in the local function where when we send the pointer, it receives the copy of pointer, so a new address has been created which is pointing to the our value. So any changes done at this pointer location will not get reflected back to the caller function. And if you want the changes to be reflected, there comes the double pointer which will going to solve the pointer, and this is termed as passed by value, so passed by argument. Now when we by using the double pointer, when we send our pointer to the function, so let us sending the double pointer, and in the local function we have changed the pointer to some value like null function call. So we have while the caller function we have sent address of this is calling function calling. So how will be the memory mapping of this in this case? So let us say p pointer is at address 1000 and address of p which is at address 2000. So now the function receive p which will if the function will be copied, the function is receiving the complete address, not just the value. So function pointer will be at address 2000. Now any changes done at this address, same address has been there also, will get reflected back. So we are changing this value as null and addresses are same, so changes will reflect. Directly working on address, so write null into pointer and this will get reflected. So double pointer, when we have to send any function the address of our pointer, so when we have the pass pointer as argument, then double pointer coming as. So this is an example of pass by argument. Above is by pass by value. So in case of argument, we are directly send the address. So changes are done at address itself, not at value. Okay. That is the reason malloc API also use double pointers. It's something like void create. We are sending double pointer to it, and in this the pointer we are simply doing malloc 100 or any number of byte we need to. So any changes in this address will get going to reflect back to the calling function itself. So this is how we receive the pointer. So the new pointer will contain inside the main function, it will simply as int value stored by buffer, which is initially point to null, and we will send this to create address of buffer. So in this function we will allocate 100 bytes of memory, and that allocated memory will be reflected in main also. So this is the practical use of double pointer. Let us understand argv, which is a very good example of double pointer inside kernel. Argv, argument vector. If you remember, our initial stack layout look like the layout which is created by the kernel itself. It has argc, argv, 0 till null, envp, 0 till null, and 0 till null, and auxiliary vector. So this is the initial stack which is created by the kernel. So what is argv? argv. This is argument vector. What it contains? Let's decode. When we send the arguments like a dot out, this is the first, and 1, 2, 3. So we are sending 4 arguments to our program using command line arguments. So how it will be stored in memory? Let us see. One memory 1000 containing 1. argc will be argument count 4, and argv 0. 0 is a dot out. And this is argv 1, 2, 3. So the array argv is of double pointer. So argv is of char pointer type. Char double pointer. So we can say that argv, and this is the pointer containing pointer, and this pointer is containing the other pointer, and after that we have character. So when we have to fetch argv1, that is at address 1000, value is, when we have to send the command line argument to the integer function, the function is simply look like int main, int argc total number of argument count, and int char pointer argv, which is an array. So by dk it will be char double pointer argv. So we can say that argv is a double pointer which is an argument vector where each parameter argv was 0. 0 is always the name of elf file, and 1, 2, 3 how many arguments we are giving to it. Okay, so this is command line argument. So when we need to send data using the command line argument, double pointers come into picture. Double pointers are also used in dynamic 2D arrays. For example, int double pointer matrix. So this will be simply like matrix is at particular address which will points to multiple row. So this pointer again containing the addresses of other pointers. So this simply means 3 rows and 2 columns, and the address of this is available in double pointer. Okay, so this will pointing to the first base address, and which will point to the array. So two in direction. We also use double pointer in case of linked list because we need to modify head pointers sometime. So they are not just magical terms. Triple pointer, 3 level of indirection. So they are simply means what the level of indirection, how many hopping we have to cover to reach the value. Now let us see what are the common mistakes programmer makes and should avoid. First is uninitialized. Always initialize the pointers as null or something. So pp is the uninitialized pointer. When we will update any value to it, it will lead to crash. Most of the people got confused in p, q. Let us take example. Pointer to q, double pointer to q. So it simply means this is address of pointer. This is pointer itself, and this is value of stored at pointer. So this is value, this is pointer, this is address. We can say that double pointer does not means complex syntax. So double pointer provide the access to pointer itself. When we have to modify pointer ownership, or we can say when we have to modify pointer destination or some pointer allocation, like in case of malloc or any replacement, we can use double pointer. So we can say that pointers store address and double pointer store address of pointer. Okay, that's all in this episode. In the next episode we are going to cover function pointer and callback architecture. Stay tuned for same. Thank you.